So what's a 24 pulse drive, and why do we typically apply them at medium voltage? A 24 pulse drive takes advantage of phase shifting cancellation of harmonics, and you're only left with, like we used that equation NP plus or minus 1, we're only left with 24 plus or minus 1 harmonics. So 23rd and 25th, 2 times that, plus or minus 1, 47th and 49th, and so forth. And because those harmonics are higher order, the magnitude of the harmonics are very small. So again, the benefit is usually these are very large drives, 300 to 10,000 horsepower motors. And so let's take a look at a picture of how that cancellation works. In the power quality lab here, we used 30 horsepower drives, and we ran them all together without any cancellation. And then we ran the same exact scenario, but with 24 pulse cancellation. And take a look at the waveform of the current, which is the taller one on the right-hand picture. You can see that the waveform almost looks purely sinusoidal. So what's a medium voltage 24 pulse drive look like? This is basically the drive, the guts of it. We have the 24 pulse transformer, and we have the power electronic converter that basically is going to do the rectification inverter. And by having 24 diodes in this case to switch from AC to DC in the rectifier part, we're enabling ourselves to minimize the harmonics coming out of the drive. Remember, again, harmonics come out of the load, in this case the drive. Let's take a look at an example now. I'm going to switch over to the camera, and we'll take a look at 24 pulse phase cancellation. So what I'll do is, this is my voltage on the system, and I'll start up all 4 variable frequency drives with the phase shifting transformers in front of them to show at the 480 volt level here what that would look like, and we'll end up with 24 pulse cancellation. So you can see the current looks very similar to the voltage. It has a very low distortion level. In fact, the harmonics that we expect are going to be way out there, again, the 23rd, 25th. So we have very, very minimal harmonics all the way out through, and we have a little bit of 23rd and 25th. But again, looking at the waveform, it's almost purely sinusoidal, and it's also very much in phase, which gives us that power factor correction that variable frequency drives offer as well. So even at a light load, we have a very good control of those harmonic currents.